Okay, and then it comes to the calibration strategy and the algorithm of the system. You can see the chapter 3 of my thesis. And then I'll explain the functions in my propeller expert system. So there are four kinds of functions in my system, and then this the first one is for communication. The second one is for status checking. The third one is for calibration strategy, and the fourth one is for data saving. And I'll explain one by one. So the first one is for communication. This function read modbus position and space. So this one the computer will read a register of the PLC, and the position is for the position in the PLC register, and if the number we want to read of the register is integer, the space equals to 1, and if it's float number, the space equals to 2. Okay, so this one is to read the register in PLC. The second one is we need to write the register in PLC. So similarly, the position is the register position of the PLC, and if it's integer, the space equals to 1, and if it's a float point number, the space equals to 2, and the value is the value you want to write into the register. Okay, so this is the first one, the functions for communication. And second one is the status checking. So this kind of function is to check if the machine is on some kind of status. So after we check its status, the system will decide to wait for the machine or send some command to the machine. So you can see here the first function is response trial. So this function is to confirm the status of the PLC. The PLC has some registers that is for the status of the machine, and our PC program will check these register to see what status the machine is. So the this one register waited is the register the program is waiting for, and the status code is we are waiting for the register to turn into this status code. For example, if the machine send back the static code, it's 3, and then the program knows knows that if it turns into 3, it can go to next step. So in this kind of situation, we'll write down response trial, the register 1, 2, 3, 3. So this means we are waiting the register 1, 2, 3 turn into 3. Okay, so next one is Z measure refresher, and the variable is numbers of rows and position data. So this is for updating the z-axis deviation of the propeller blade. So if you use this function, it will update the deviation of the propeller blade immediately. So usually we use this function after overall test or any step with measuring the blade. So the number of rows means which detection points we had, and the position data means the deviation data recording in the PC program. And then is discount refresher. So this is for updating how many times a single detection point has been tuned. So if you use this function, it will update the how many times the points has been tuned immediately. So usually we use this function after the machine apply displacement to the propeller blade. Okay, so this is the functions using for status checking. And then the third one is for the calibration strategy. The first one is solver. The solver is trying to solve a polynomial function of the curve data. You can use this function to solve this kind of formula. So the AP value here is the relationship of displacement and deformation using polyfit function to get ABC value here, and fx is the deviation, and max I is the maximum recommended value of the calibration. So it use iteration to solve the TR1 value, and this value is the recommended calibration value. And then next one is continuous tuning. So this function using the distribution of the deviation, we decide the range of the continuous tuning and what value to apply. So it's So you can see my thesis in chapter 3. DF is the deviation data recording in the PC program. So this is the functions for calibration strategy and the algorithm. The fourth one is data saving function. So this one, data frame writer, is to after we get the real displacement deformation relationship, we'll save it into a into a data frame. So the site name is the edge where the current detection point belong, and the displacement is the displacement we apply to that detection point, and deformation is the real value we measured after we applied displacement.